This lesson builds on the last lesson we learned, where you derived and anti-derived the natural exponential function, e to the x. Now we're going to work with bases other than e. We're going to start with differentiating bases other than e. We're going to work with both logs and with exponential functions with different bases. We work with natural log and e to the x, so now we're going to work with different bases. So, the derivative of a to the x, some base to the x, is going to be the natural log of a times a to the x. Now this still works with e, because the natural log of e is 1, so the derivative of e to the x is natural log of e, which is 1, times e to the x. So it still just leaves you with e to the x. So this still works with e, except you don't usually say natural log. You don't usually use this rule. You just use derivative of e to the x is e to the x. And again, our chain rule, derivative with respect to x of a to the u, natural log of a times a to the u, leaving it the same, times the derivative of that exponent, times du dx. Now if we have a log, derivative of log base a of x, talking about something other than natural log, is going to be, still have the 1 over x, like you did with the natural log, but you also have the natural log of a on the bottom also, the natural log of that base. So it's 1 over the natural log of the base times whatever that term was, that x. Derivative with respect to x of log base a of u. Again, chain rule type problem. It's going to be the same thing, 1 over u times du dx, but also the natural log of that base is on the bottom there. So these are the rules for differentiation with bases other than e. A to the u or log base a of u. Now these are going to be something you just want to memorize, very similar to the e to the x and the natural log functions. One little addition here, so it's something you're going to have to memorize. These don't come up too often. Most of the time you see things for application problems are usually written in base e or as a natural log. But if this does come up, you do want to have this committed to memory. So we'll do a problem here. Y equals 7 to the 3x squared plus 1. So it's going to be 7 to the 3x squared plus 1 times the derivative of that exponent times the 3x squared plus 1. So you get 7 to the 3x squared plus 1 times 6x. But since the base is other than a, you're also going to multiply by the natural log of the base. The natural log of 7's in there. So you still have this to the same power, this exact exponential expression, times the derivative of the exponent. But at the end, you multiply by the derivative, by the natural log of the base. So one extra step when the base is other than e. Now we'll do a log example. Y equals log base 6 of sine of x. It's still going to be u prime over u. So you still get the derivative of sine of x is cosine of x. Sine of x still goes on the bottom. But now, in addition to the natural log differentiation, when it's not base e, when it's not a natural log, we also have to throw the natural log of that base on the bottom there. So you get u prime over u with the natural log of the base also in the denominator. So you get cosine of x over sine of x, which can be rewritten as cotan of x, with the natural log of 6, which was your base in the denominator. Integrating bases other than a. So we have an exponential function, the integral of a to the x dx. Well, when you derive a to the x dx, it's a to the x dx times the natural log of a. So when you anti-derive a to the x dx, you're going to still have a to the x dx, but you're going to divide by the natural log of a. So it's 1 over natural log of a times a to the x, and again you have your constant of integration. All those old rules still apply. It's just a new formula. So, I'd like you to find the integral of 2 to the x dx. Try that. Pause it for a second. Try to find this. Should have gotten 2 to the x, stays the same, and now you're going to divide by 1 over, or multiply by 1 over natural log of 2, or divide by natural log of 2, and add your constant of integration at the end. So, some rules for bases other than e, whether it's a log base a or a to the x or a to the u expression. We add that one little step where you're going to throw the natural logs in there as well.